let's get started. Because the training progress is so time consuming, so here I just use 10,000 as a demo to show some result. And so let's begin to train. Okay, my project is to implement the deepid for face recognition. So you can see there are many applications in our daily times using the face recognition, such as the Alipay's mobile payment and iPod's Face ID. This picture is a traditional scene. You can find it contains input layer and a convolutional layer and a polling layer, a convolutional layer, a polling layer, and so on until the fully connected layer and the output layer. The convolutional layer is a layer to do some convolution operation. So this convolutional layer uses the convolution kernel to extract some features in the image. So you can see the yellow one is the feature of this part, and each result can be regarded as a feature. Then we talk about the polling layer. We usually use the max polling layer. It's an operation of the downsampling, so we can reduce the parameters used in the neural network. It can save a lot of time and energy. Also, it reserves the sharpness of the image, such as the age of a specific people. So when the pixel is slightly displaced in the neighborhood, the output of the polling layer is unchanged because we usually concentrate on the maximum value of the entire kernel. So this is a picture of fully connected layer. You can find it integrate all the features into just one value. So you can ignore the influence of the position of one specific feature, because if you have a feature on the first neuron or on the second neuron, it doesn't matter because we combine them together and get a single value just. This is the network structure of deepid. So the most significant difference between deepid and other traditional systems is deepid's fully connected layer. We call it deepid layer. After the third max polling layer, instead of simply connecting it to fully connected layer, we do a fourth convolutional layer and connect the output of the third max polling layer and the fourth convolutional layer together to the fully connected layer. So then we use softmax activation function to classify. So the method is effective because the higher layer of the convolutional neural network, the larger the field of the view. So such a connection can consider both local features and global features. Utilizing the third layer, we can reduce the possible information loss in the first convolutional layer. Yeah, I use YouTube face as my dataset. So you can find it through this link. The first thing I do is to pre-process the image. So I change the original images by randomly adding brightness, contrast, and flipping image to make the data more representative and add this image to those people who do not own 600 faces. So then you can see the left one is the original image and the right one is the result image. Then crop the image to the same size so we can process them easily. This is the running environment. Here I use TensorFlow GPU and NumPy. Also, I use the GTX GPU for training and test. This is how to run the deepid program. So first we should download the YouTube face to the origin folder and then run the image augmentation .py and then run image crop.py, then image split.py, then image vector.py, then train.py. And about the code and some details, please see the code parts. This is the result of the accuracy. We can find the neural network converts very fast and it can get almost 100% accuracy. And the loss is almost zero. So we get the conclusion: I successfully implemented deepid algorithm training on YouTube face database by representing a large amount of different identities with a small number of hidden variables, highly compact, and discriminative features are accurate, and the feature extracted from different face regions are complementary and further boost the performance. In the project, I achieved a 98% accuracy on the valid dataset and 96% accuracy on the test dataset. Okay, let's go to the code part. Yeah, you can see we got about 95% accuracy after 10,000 iteration, but in the whole project I trained it about 100,000 times, and this is the train.py, and we usually mostly we get the model.py. This is a field to define our convolutional neural network. You can see this function. We define a convolutional layer and a max Pooling layer. If this attribute is true, we usually just have a convolutional layer. This is the function we use to construct our neural network. And you can see each input and output. I write comments on the right. Here is our deepid layer. You can find we combine the H3 and H4 layer, and we got 160 neurons on this layer. And we use softmax as the activation function and Adam as the optimizer, and change the learning rate every 40,000 iterations. Yeah, we have time. Um, so I want to run a test.py. This one we set a threshold to distinguish people, and you can find that the distance is defined by cosine distance. Yeah, we get the result is got from the sklearn accuracy score, and you can find we got 87% accuracy. So that's pretty good. We can see that. So this is a field to image augmentation, and this is for image crop, and this is for image split, and this is for image vector. Okay, that's all. Thank you.